Okay friends, welcome to this class of plate tectonics, and today we are going to initialize a new topic that is called plate tectonics and mineralization. So before going to talk about plate tectonics mineralization, we should know the background, how the mineral systems forms and how it can be an extractable material which enriching the mineral for us. So that means you can say who is the natural money makers. So in which process the minerals are concentrated and which part they are concentrating on the earth crust, and particularly in relation to plate tectonics, how the mineral systems are evolved and concentrated at different plate boundary settings. So, if you see these diagrams, we know that plate tectonics mostly there are three types of plate boundaries like the divergent, the convergent and the conservative. And all these three types of plate boundaries, they are prone to generate minerals, and some plate boundaries, though the minerals are formed, may not be preserved because of the lack of suitable geological environment or geochemical environment. But in certain cases, the minerals are preserved and we are able to extract it economically. So, if you see here this divergent plate margin and this divergent plate margin here, the two plates they are separating from each other and there is a continuous magmatic supply. And if you remember our earlier class when we are talking about the divergent plate margin settings, we are talking about the hydrothermal leaching of this mineral. The water is going down and it is hitting and coming back, and once it is interacting with the cool sea water, the pH changes and the VHMS, volcanic hosted massive sulfide deposit, they are found here. Similarly, at this plate boundary, we have the black smokers, the white smokers. They are rich in minerals and volatiles. Whenever they are reaching to this water level at the sea, so this pH changes, and with reaction with that, so minerals precipitate and we are getting the deposit. But now the question arises, when it happens, whether these minerals can be extracted near to this mediosinic ridge, because we know this mediosinic ridge, the basalt which is formed here, that is going down and it is subducting here. So there is very hardly getting chance that these mineral can be extracted, because starting from the mediosinic ridge to the subduction zone, nowhere it is exposed. But at times these part of this basaltic system or the lithosphere, they are abducted at the ophiolite sequence. So they may be the potential site for extraction of these minerals. So that's why though we have plenty of minerals found here, but hardly this type of tectonic setting giving us a chance to extract those minerals economically. And next come to this convergent plate margin. Here this plate is going down and here partial melting taking place of this mantle, and this mantle material is erupting here at volcanoes, and we have the volcanic clasts and the stratas. So, they are containing the mineral volcanic rocks, they are containing the minerals. And here is the conservative plate margin. So, the divergent plate margin, as we have discussed, it is rich in mineral, and in the conservative plate margin, here these minerals which are formed here, they are dissected and relatively separation that occurs here and redistributed. These blocks are redistributed by the transform fault. So, that means by and large every type of plate boundary, they are responsible for the mineralization purpose. Addition to that, before reaching this divergent system, we started the journey from rifting. So, rifting is a suitable environment for mineralization. So, that means from rifting to drifting, and from drifting to subduction. So, all these type of tectonic environment, they are suitable for mineralization. However, the nature of mineralization and these components of mineralization are different at different plate tectonic setting. Addition to that, here we have regional metamorphic system, we have contact metamorphic system. So, the minerals which are formed from this magmatic source that are modified by this metamorphic system. And similarly, before reaching this, that is the Mineralisation ridge system, we had rift basins, and the rift basins particularly they are rich in evaporites. So, that means every stage of plate tectonics starting from rifting to drifting and this subduction and subduction related metamorphism, magmatism, everywhere we are dealing with the minerals. But now the question arises, how much these minerals are enriched with respect to this crustal abundance, so that we can go for directly mining without any beneficiation. So, these mineral deposits that form through this coincidence of a favorable geological process. What is a favorable geological process? Then in a given spatial setting, then in a specific geological time, then it is a tight time window. Now you see how much restrictions are implemented here. There should be a favorable geological process. What is a favorable geological process? That means all the geological processes, they are not favorable for mineralization. Then that is a given spatial setting. So, spatial setting, for example, I am talking about rift. Rift cannot be nth extent. So, there should be a boundary up to which the rifting effect can be felt. So, a spatial setting that is restricted. Similarly, in a subduction setting, you cannot say the whole earth is affected by subduction. So, particular subduction zone, it affects to a particular region. So, the spatial tectonic setting. Then in a specific geological time. So, specific geological time, that means we have a geological time everywhere we do not get minerals. So, probably you know in your BSc level that was talk about this mineralizing that province or metallogenic province and metallogenic epoch. So, in that case some specific time is there, that is the metallogenic epoch that is responsible. Then at last in a tight time window, that means you cannot extend the mineralization process to millions or billions of years. So, there is particular time, and through this time, that means in a process that all starting from the process to the end of the process, you cannot expect mineralization. So, there is a particular combination and permutation through which that time is suitable for mineralization. So, that means after all these permutation combinations, we are getting a mineral, and that mineral is sufficient for extraction, and that we are using nowadays. See, processes that are formed mineral deposit can collectively turn a mineral system. Like petroleum system, similarly we have a mineral system, and that is defined all the geological factors that control the generation and preservation of a mineral deposit. That is very important. Not only generation of mineral is important, preservation of mineral is also important. So, otherwise we generated a mineral either from magmatic process, from metamorphic process, from hydrothermal process, from sedimentation process, but it is removed by weathering, removed by erosion, removed by oxidation. So, it does not mean anything. So, that means not only the generation is important, but preservation of mineral is also important. And those processes, that is the geological processes, that includes the geological settings. Which type of geological setting? Is it a rift setting? It is a subduction setting or other type of setting? Then the driver. Who is the driver? Who is taking the mineral components or the constituents from one place to another, from mantle or from the lower crustal level to the upper crustal level? Because if a mineral is occurring about 10 kilometer depth, it hardly matters to us. So, we need a mineral which is close to surface. So, that means we need a driver who will take these minerals from deeper level to a shallow level. So, that driver may be hydrothermal fluid, maybe magma itself, maybe thrusting, maybe faulting. So, who is the driver? Who is taking these minerals from lower stratigraphic horizon to upper stratigraphic horizon? Then timing and duration of mineralization. So, when this timing, when this mineralization occurred, and what is the duration of mineralization? If the duration of mineralization more, we will get more mineral. If it is less mineral we will get. So, when and what is the duration of this mineralization occurred? Whether the mineralization it is timing wise, it is a Precambrian time, it is in Cretaceous, it is in a recent time. So, all that matters. And the mineralization fluid and its component. What is the mineralization fluid? Whether the fluid is crustal derived, the fluid is magmatic derived, the fluid is hydrothermal derived. So, that is matter, that means what type of mineral it will give rise, that depends upon the fluid components and fluid origin of this fluid. Then the pathway along which the fluids flow. So, which pathway this fluid is flowing? It is flowing through sedimentary rock, flowing through faults, flowing through folds, flowing through fold axis, or it is igneous rock or metamorphic rock, or that is pore spaces are already available, or it is created its own pore space. Then depositional site, that is the trap site. Then where is it depositing? Within depositing, it is forming the mineral within the igneous rock, it is forming mineral within the sedimentary rock, and then it is post depositional modification. Post depositional modification means after the formation of the mineral, how it is modified, whether it is modified by this weathering effect, it is modified by the metamorphic effect, or it is remobilized due to exhumation. So, all these factors that is affecting, and finally, it is giving rise to mineral deposits. So, this mineral formation and its preservation up to extraction, it is not an easy process, it is going to several processes, and this product is finally we have a mineral and we are going for mining. So, a mineral system involves the concentration of commodities like these metals through a number of different processes to the point at which the concentration is sufficient to consider exploration. Otherwise, mineralization is there, minerals are forming, but it is not concentrated. So, we have different cutoffs for different minerals. So, if it is concentrated below, so it is hardly of our use. So, when this commodity can be extracted economically, the product of a mineral system is an ore deposit. So, that it is sufficiently enriched, sufficiently concentrated, so that we are extracting it economically. So, that we are saying it is to be a deposit, either it is ore deposit or a mineral deposit. And the processes operate at scales starting from global scale to microscopic scale. Some of the geological processes that are extending to global scale, for example, it is crustal differentiation. It does not obey your political boundary, continental boundary, it is global scale. And magmatic processes including melting, melting may be localized, fractionation may be within that magma chamber, then crystallization, magma mixing, immiscibility, and magmatic hydrothermal fluid evolution, hydrothermal process including leaching and depositional process such as boiling, fluid mixing, then cooling and fluid rock interaction. Physical processes include density separation, biological processes, and post depositional enrichment and upgrading. So, that means these are the processes involved for mineralization, and mineralization when I am talking about economic mineralization, because we need money. So, who is the money maker? Who is the natural money maker? Out of these processes that we are describing, all these are, they are just involved to making, enriching the mineral commodity for us. So, these are certain elements and their global distribution, that is crustal distribution. So, throughout this crust, if you remember our earlier class, we are talking about the compositional stratigraphy. different elements, they are compositionally stratified from crust to core. So, now the question arises, when we are interested for a certain type of mineral and we want to extract it economically, that means this type of global distribution or the crustal distribution, it hardly matters to us. So, this matters to us that where this type of element of interest, they are concentrated. Now, the question arises, who is concentrating that? That is the geodynamic process, that is the tectonic process. So, this from global distribution or this crustal distribution to particular area enrichment of a particular mineral, that is done by the tectonic process. And the tectonic process that involved all these hydrothermal fluid, magmatism, metamorphism, thrust movement, fault movement, all those things, they are related. And addition to that, weathering and erosion, they are also concentrating minerals for us. So, to getting a mineral deposit of economical use, these type of processes, they are given the credit. So, economic extraction of many commodities require extreme enrichment relative to bulk earth average continental crust. So, here the bulk earth crustal composition is given, and some of these minerals we need very less enrichment and some it needs very high enrichment. For example, here with few exception, iron and aluminum, the formation of an ore deposit requires enrichment factor generally excess of 100, and some cases the excess of 1000 like platinum, gold, like this, and relative to continental crust, and the host is virtually all ore deposits. So, here this is the differentiation, magmatic differentiation or the crustal differentiation, that means how the crust was differentiated during the formation of the earth. So, we have elemental stratigraphy, compositional stratigraphy. From there we are going to this crustal level, that means you see with the upper crystal level with the timing, and this is the fluid system or this is the evolving system, how this geodynamic system is evolving, and it is giving from crustal differentiation to mineral deposit. This is the source of metal, fluid, and that is the legends and sulfurs like that. So, these are the different geodynamics and tectonic processes, how from this crustal distribution to enrichment it is reaching. So, these geodynamic process at different plate boundaries, specified spatial distance. So, these are working in that domain and giving rise the enriched mineral deposit for us. So, this enrichment factor relative to bulk earth are extremely variable, with ore grades for some commodities such as nickel, iron, platinum lower or approximately equal to the bulk earth concentration, and these commodities are strongly concentrated in the core. Some commodities such as this tungsten, tantalum, uranium and Pb have enrichment factor in excess of 10,000 relative to the bulk earth, as the elements are highly concentrated in the continental crust. So, that means depending upon the mineral, the concentration changes and depending upon our requirement. So, here some of this enrichment factor of some common minerals are given. Here you see the gold, we need 500 enrichment factor. So, the bulk crustal distribution, it is not enough. So, someone should be there who will enrich the gold 500 times compared to this global distribution, so that we can extract it economically. So, now the question is, who is doing it? Who is making money for us? This is the tectonic process. This is the geological process. So, the tectonics process in a particular geological area, in a particular geological time and in a particular duration, this process becomes active. And we need a suitable tectonic environment, a suitable geological environment for such enrichment. For many mineral systems, the first process of concentration was initial chemical differentiation of this earth. And many commodities of the economic interest, for example, the series of minerals are given here, are highly enriched in the crust relative to the bulk earth, whereas other commodities are weakly enriched in the crust. and other are not significantly fractionated like Ag. Some elements are fractionated into this mantle and core either moderately or strongly. For example, nickel and platinum group of element, mostly that are in the core, and in the crust their abundance is very less. So, some are very strongly fractionated at the crust and some are strongly fractionated at the core and some are they are distributed throughout that. So, by and large we need these elements, for example nickel and Pg, and we know most of this nickel and Pg they are at the core level or the lower mantle level. So, now we need a process, that process has to track these minerals and these minerals should come near to the crust. So, that process that is driven by the tectonic forces, and small number of commodities like molybdenum and Au have complex distribution being enriched in the core and crust relative to the mantle. So, following this initial chemical differentiation of this earth, that geodynamic process further fractionate the commodities within the crust to this upper mantle. So, now you see from this crustal fractionated this geodynamic process, it is fractionating it again and it is taking to this upper crustal level. These processes which operate at this cratonic to province scale generally occur along active tectonic margins and can include processes such as mantle metasomatism, the formation of mafic and underplate and many others. So, these are these processes which are responsible for enrichment of these metals or minerals. The combination of the initial global chemical differentiation and subsequent tectonic enrichment that is associated with magmatic and metasomatism, that is hydrothermal processes, redistributed the mineral commodities and taking from the deeper level to shallower level. And superficial processes like weathering that we have discussed and sedimentation in some cases produce regions of the upper mantle and crust that act as a source of the commodities and that are concentrated into mineral deposit by hydrothermal and magmatic processes. So, that means we have a elemental distribution at a different part of this globe at a different stratigraphic level, and these hydrothermal processes, magmatic processes, they are recycling it, and due to this recycling process it is coming to this surface or near surface and which can be mineable. In addition to the producing geochemically fertile metallogenic province, tectonic process initiate crustal and province scale architecture that is critical for the movement and production and later ore forming fluid. So, we have ore forming fluid, we are taking from the deeper level to the shallower level. Now, where to put it? We need a room, suitable room it is needed, and that is the tectonic forces that create rooms for that. It is fold axis, that is the fault zone, that is the shear zone, that is the basin that is formed by these tectonic forces. So, not only fluid creation or mineral rich or metal rich fluid creation is important, it should have sufficient room to accommodate those minerals, those metals, and the tectonic force not only create this or recycle this mineral system, it also create rooms for them. In many cases, this architecture is developed early in the tectonic history of a mineral province. In some cases, tens to thousands of millions of years prior to mineralization, with the fluid flow facilitated by reactivation of the pre-existing structure and architecture. So, that means during the metallogenesis or during this mineral formation, either the room was formed or the rooms were earlier existing by this pre-tectonic system, pre-tectonic events. In contrast, the time involved in the formation of mineral deposit may be relatively short, in many cases in order to 1 million years or less, system associated with magmatism. So, once room is available, whenever we are producing minerals by any of the processes, we can provide sufficient room for that. Otherwise, we will create minerals, but we do not have room, so that we cannot preserve it. The final concentration of commodities by hydrothermal or magmatic processes generally occurs during critical window of time, during which hydrothermal fluids or magmas are driven along structures or other zones of permeability. That means we have structures like fault, like fold axis, this is the axial planes, like the shear zones. These are nothing, these are the pathways, and these are providing this permeability for this, the rooms for mineralization. And the presence of such fluid or magma pathways at the time of mineralization is one of the most fundamental key to the formation of significant mineral system that we have already discussed. If we do not have room, so creating mineral is useless. So we need a sufficient space to preserve these minerals, and that sufficient space is also created by tectonic forces. The drivers of fluid may be the hydrothermal fluid, may be the magmatic fluid, may be the brines. So that may flow in temperature gradient, or may be magmatism, which produce hydrothermal convection, that is on-roofing via erosion, tectonic forces, stress changes, then magmatic buoyancy, and release the magmatic hydrothermal fluid during magma crystallization, and metamorphic devolatilization, and during contact or regional metamorphism, formation of explosion of basinal brines, hydraulic pressure gradient caused by contractional or extensional deformation, and other processes. So, suppose we have the fluid. Now, how to drive this fluid from lower crustal level to upper crustal level? So, these are the processes. These are the processes that accelerate or they help the fluids to flow. So, this become the driver, and that may be due to tectonic forces, that may be stress change, may be magmatic buoyancy. That means on-roofing via erosion, we are on-roofing, we are releasing the stress, releasing the overburden pressure, so that this fluid is coming up. So, these are the drivers of taking these fluids from lower level to upper level. And in some cases, production of a fluid is slow relative to its flow. So, we need a flow, but its production is slow, and particularly this case it is the metamorphic devolatilization. So, metamorphic devolatilization is a slow process. So, that means we need some other thing, that means to release that fluid from this pore spaces. So, that other thing, that means this other support is supported by this seismic pumping. For example, suppose there is some metamorphism, the metamorphic system is going on and the fluid is releasing, but this release of fluid is very slow process. So, in that case, suppose there is a seismic activity, there is seismic shaking. So, once there is seismic shaking, so that means it is providing suitable geological environment, so that this fluid which was released very slowly, that can easily escape. So, the seismic pumping sometimes it adds as a driver to flow the fluid from this system. So, fluid flow pathways may from prior to or during the fluid movement. So, that include extensional structures, that is faulting, then developed host basins by volcanic terrains formed and reactivated during subsequent tectonism, permeable zones formed during basin development and diagenesis, and structure formed during these events. So, that means this before this fluid generate, we should have sufficient rooms, and the rooms that is created or the pathways that are created by volcanic terrains, by crustal extension, by rifting, and by tectonism. And suppose there is earlier the fault was there, the pathway was existing, but it is choked. So, during subsequent tectonism, that may be reopened. So, that means I want to say tectonic not only creates the fluid, tectonics creates the pathway, tectonics provides the room. So, that means all total system it is driven by the tectonic itself. And the formation of a mineral system requires the concurrent availability of a driver a metal source, a fluid pathway during the discrete critical window, and these are triggered in many cases by the specific tectonic events or switches and may be relatively short lived. So, if you are not providing the room, so that means it will go to the van, because this metallogenic process, it is a short lived. So, we should be ready with our pathways, with our rooms, so that whenever this metallogenic processes occur, we should provide that room. Yes, come and accommodate here. In addition to the mineral system requirement, formation of significant mineral and ore deposits require two other features. What are the two other features? A hurdle that concentrated fluid flow. Fluid is there, it is flowing. So, we need to stop its flow so that it will give us mineral. Otherwise, it can flow to nth extent along this path, and finally it will release to the surface. If it will be oxidized, there will be no mineralization. So, that means it should concentrate, that means we need a hurdle, we need a barrier like the petroleum hydrocarbon, we need a trap, we need a cap rock, so that it will hurdle and it will stop its migration. Similarly, when this fluid is migrating from the lower crustal level to the upper crustal level, we need a hurdle so that it will stop its further movement. And a gradient which can be either chemical or physical or both, that cause efficient deposition and segregation and trapping of commodities in the economic interest. In hydrothermal mineral system, common causes of mineralization include rapid change in temperature, pH, redox caused by water rock reaction and fluid mixing. However, in the magmatic system or other hydrothermal system, physical changes such as depressurization can include chemical and physical reactions, that is boiling and volatile loss that cause the mineralization. So, that means I want to say different processes are responsible for mineralization, and all these processes, if you trace them back, they are triggered by tectonism. And in some hydrothermal system or some orthomagmatic systems, these chemical changes such as magma mixing or contamination by wall rock can produce immiscible melt or cause crystallization of minerals containing the commodity of interest. In magmatic system, phyllon enrichment to form mineral deposits results from density driven physical process and physical trap that control the location of a mineralization. So, this is the magmatic differentiation, density driven physical process, that is the concentration. Suppose we have a magmatic system, we can remember our buoyancy reaction series. First, the olivines among the silicates they are forming, and they are settling down at the magmatic system because their density is more. So, the density driven physical process. So, in the later on we have quartz, feldspar like lighter element. So, that means within a magmatic system, the high density mineral they will occupy the bottom, and the low density they will occupy the top. So, these are these density driven physical processes, that is in the orthomagmatic system they are responsible. So, thank you very much, we will meet in the next class.